right, the first thing we have in this Chapter 9 review is um, writing two different representations of each polar point. And we want to make sure that one point has a positive radius and one point has a negative radius. So what you should be doing is drawing a little sketch of where this point falls. So face pi over 4 and walk forward five units. So we want to come up with two other ways to land on this point. So one of the ways is if we have a negative r. So if we're walking backwards, we must be facing the opposite direction. So one thing that I always do just to get the negative r is just give the opposite facing angle. So pi over 4 down here is 5 pi over 4. So if you face 5 pi over 4 and then walk backwards 5 units, you should land at that same point. So here's one representation. And then if I want another value with a positive r, you just need to come up with another way to face pi over 4. So the most two common ways would be you could just add 2 pi to pi over 4. So some of you would say, like you did this on your quiz, some of you said coterminal to pi over 4 is 9 pi over 4. So you could use 9 pi over 4. That's a full circle plus an extra pi over 4. Or I like to do the negative angle. So starting at 0 and rotating around, thinking like, well, how far is that? So if this is pi over 4, this would be negative 7 pi over 4 around. So that's usually what I do, but it's up to you. So either face negative 7 pi over 4 and go forward 5, or face 9 pi over 4 and go forward 5. That would be acceptable as well. There are infinitely many answers because you can add or subtract any number of 2 pi's to either of these answers and just keep generating more values. All right, so same thing with number 2. So we're going to face 2 pi over 3 and walk forward 3 units. So here's 2 pi over 3. So my negative r, if I want to walk backward 3 units, I should be facing the opposite angle. So this is 5 pi over 3. So there's one answer. If I want another positive 3 radius, I've got to come up with another way to be facing 2 pi over 3. So I'm going to go the negative route. So what's the negative pi over 3 angle that goes across 3 quadrants, or it would be in quadrant 3 if it were positive? That's negative 4 pi over 3. Or again, you could get that by subtracting 2 pi, or you could add 2 pi to 2 pi over 3. So that would be 8 pi over 3. So you could also say face 8 pi over 3 and walk forward 3 units. All right, for this one, negative 5 pi over 6. So it's a negative angle to start with. So face negative 5 pi over 6. Now you're facing this way. I'm going to angle it a little bit better. 5 pi over 6 is a shallow one. So face negative 5 pi over 6. So that's this angle that we're talking about here. And walk forward 8 units. So you're in quadrant 3. All right, so if we come up with the negative angle, negative 8, what will we be facing? So the opposite of that is pi over 6. So we could face pi over 6 and then walk backwards 8 units. We have a few options for how to look at negative 5 pi over 6, face that another way. So this time I could use the positive angle. I'm used to starting with positive and using the negative, but if we're given the negative, what is this quadrant 3 angle? The positive version of it is 7 pi over 6. So you could say face 7 pi over 6 and go forward 8 units as well. So if you got an answer different than mine, whether it's for my negative r or my positive r, add or subtract 2 pi from my answer, whatever one it corresponds to. And if you get your answer, then you have another answer that's correct. If not, then you made a mistake somewhere. All right, convert each polar point. So each polar point, which is r theta, into rectangular form, which is xy. There's only one correct answer for each of these. So I'm not going to prompt you like this on the test, but polar coordinates have infinitely many ways to be rewritten, whereas xy, there's only one way to go left or right, up or down to land on a point. So for all of these, you're given r and theta. How do you get an x and a y out of an r and a theta? So again, part of part of this chapter is really just memorizing a couple of formulas and a couple of relationships. So if you're given r and theta, x and y is, write this down, x and y is, x is r cosine theta and y is r sine theta. If you need a refresher on why that's true, it's in our notes. Go back and look at the little right triangle that we created. But otherwise, memorize that formula. So you're given the two things you need. You just have to do the math and simplify. So our xy coordinate is going to be 3 times cosine of pi over 6 and 3 times the sine of pi over 6. Now, I noticed that some of you wrote that down correctly on your quiz and then mixed up your trig values here. So you've got enough time to write out our little unit circle, just the one that you need. You need the angle for pi over 6. So at this point, the cosine is radical 3 over 2. So 3 times radical 3 over 2. And the sine is 1/2. So you have enough time to write this out, or you should have enough time to write this out on your test. So, don't force yourself to do everything in your head, especially if you made a mistake on your quiz. It's better to write down what point you're using when you're just trying to evaluate trig. We do this every week for speed quizzes, so I understand why you would want to do it in your head, but it's nice to write it down too. Okay, next one. So xy is going to be negative 2 times the cosine of 5 pi over 3 and negative 2 times the sine of 5 pi over 3. 5 pi over 3 is quadrant 4. So I'm reminding myself of that so I get my positives and negatives correct. So this is negative 2 times, all right, what's the pi over 3 coordinate? So pi over 3 is radical 3 over 2. No, it's not. Pi over 3 is 1/2 radical 3 over 2. That's the pi over 3 angle. So, and then in quadrant 4, cosine's positive, so 1/2. And sine is negative in quadrant 4, so negative radical 3 over 2. All right, so negative 2 times 1/2 is negative 1. Negative 2 times negative radical 3 over 2 is positive radical 3. So here's our xy. If you have time, you can sort of conceptually check your work. What we're saying is if you face, for number 4, if you face pi over 6 and go forward 3, you should land in the same place as if you start at 0, 0 and go right 3 radical 3 over 2 and up 3 over 2. Or for this one, if I face 5 pi over 3 and go backward 2 units, I'd be in quadrant 2. I should land in the same spot if I start at the origin and go left 1, up radical 3. If you notice that the angle is a non-quadrant angle, you can also just sketch this, face pi, go forward 10, and then just say, okay, what would that be as an xy coordinate? From 0, that's left 10, and up or down 0. So there's the x or y coordinate. Or you could do the math on it and get the same answer. For this section, we are converting each rectangular point, xy, to polar point, r theta. There are infinitely many correct answers. Again, I'm not going to prompt you with that on the test, but if we're answering in polar form, there are many ways to answer that. It is a good idea to plot these points to figure out which quadrant theta is going to fall in. So just do a little sketch to say, if you were to plot this point, you would go right and down. So you're in quadrant 4. That's going to affect which theta I pick. How do I figure out r and theta based on x and y? So r is calculated with Pythagorean theorem, and theta is calculated with a tangent function. And then you pick the correct angle, pick the correct quadrant based on where the point should fall. Okay, so let's do r first. When we square 2 radical 2, you're squaring the 2 and you're squaring the radical 2, multiplying them together. So 2 squared is 4 times 2, excuse me, is 8. Excuse me. And then when we square a negative, we still get a positive. Square root of 16 is 4. Excuse me. Tangent of theta is y over x. So negative 2 radical 2 over 2 radical 2, which divides out to negative 1. So we should know by now that tangent is equal to 1 or negative 1 at a pi over 4 angle. And then again, I want to choose the quadrant 4 angle because that's where this point is sitting. It's in quadrant 4. So what's the pi over 4 in quadrant 4? It's 7 pi over 4. And then I'm going to write my polar point as r theta. So 4, 7 pi over 4. And double check your work. Face 7 pi over 4, go forward 4 units, should land me in quadrant 4. If you wrote 3 pi over 4 for quadrant 2, you would go backwards 4. So negative 4, 3 pi over 4 is another possible answer. All right, so let's plot this point for number 8 first. We would go left and up. So theta will be in quadrant 2. Let's calculate r. It's the square root of negative 5 squared is 25. Radical 3 squared is 3. Plus 5 squared. This is the square root of 100, which is 10. Tangent of theta is equal to 5 over negative 5 radical 3. So make sure you're doing y over x. The order matters there. That'll determine whether you pick pi over 6 or pi over 3. Again, you can write down a portion of your unit circle to help you with this, but the angle that makes tangent 1 over radical 3 is at pi over 6, because that's where we have radical 3 over 2, 1/2. So pi over 6, and then I want the quadrant 2 version of that. So theta is 5 pi over 6. So my polar point is 10, 5 pi over 6. All right, and if you notice you have a point that's on the x or the y axis, then you can get away with not doing all the math for this. So plot the point, negative 7, 0. And then what would this be as a polar point? Well, you're facing pi, and you're walking forward 7 units. You could also face 0 and go backward 7 units. So negative 7, 0 is actually also what the polar coordinate would look like. But I just like to keep r positive for this section. All right, now when we had this quiz, a few of you kind of forgot what the correct form of a complex number, like how that should be written. So when I said write each complex number in polar form, some of you still wrote them as polar points. So you had the correct number for r and you had the correct number for theta. You just wrote the number in the wrong form. So the nice thing about these is if you forget what a complex number in polar form looks like, just take a look at the next section. Here's a complex number in polar form. It's right there. It should look ugly like this. If you forget what rectangular form looks like, just take a look at these. These are a rectangular form. So again, if you missed this section on your quiz, go back and rework those and study that. What do these different forms look like? So a complex number in polar form is z equals r times the quantity cosine theta plus I times sine theta. And a complex number in rectangular form is r equals a plus bi. All right, how do we find r and theta? The same way we did back here. That's why I understand if you got confused, but it also comes down to just studying that a little bit longer or a little bit more thoroughly. So I'm still going to find r with Pythagorean theorem using the a and the b, but not the I. So r is equal to the square root of 2 radical 3 squared is 4 times 3 plus negative 2 squared, so plus 4. 12 plus 4 is 16, so square root of 16 is 4. We still find theta using tangent, so negative 2 over radical 3, over 2 radical 3, is negative 1 over radical 3. And how do I know which quadrant to choose in? You still get this by plotting the point. Imagine we're in the complex plane where we have the real number axis and the imaginary axis. To plot this complex number, you would go right and down. So I want the quadrant 4 answer for theta. All right, so take a look at number 8. Pi over 6 is the reference angle. So in quadrant 4, that's 11 pi over 6. All right, so put it all together. You've got r and you've got theta. So z is equal to r times the quantity cosine of 11 pi over 6 plus I times sine of 11 pi over 6. That's polar form of a complex number. Same idea for number 11. So let's find r. Well, let's plot where the point is first. So imaginary axis, real axis, you would go left and then up. So we're in quadrant 2. Okay, and then find r. So when you square negative radical 5 over 3, it becomes positive 5 over 3 squared is 9. Same thing for this one. 5 ninths plus 5 ninths is 10 ninths. And then separate the numerator and denominator. So radical 10 over square root of 9 is 3. Tangent of theta is equal to radical 5 over 3 over negative radical 5 over 3, which divides out to negative 1. We're in quadrant 2, so theta should be 3 pi over 4. And then write your final answer. Oh, this just crashed on me. Write your final answer in, of course, in the correct form. So z is equal to radical 10 over 3 times the cosine of 3 pi over 4 plus I times the sine of 3 pi over 4. Right? I am going to try to do these last two, and then I better save this video and split into another video before I lose the video again. All right. So this should be the easier version. Start in polar form and get into rectangular form. That just means clean this up, like get rid of the trig by evaluating and get rid of the parentheses by distributing. So z is equal to 4/3 times the cosine of 5 pi over 3. So again, I'm thinking of what's the pi over 3 coordinate? It's 1/2 radical 3 over 2, and I'm in quadrant 4. So cosine is positive 1/2. Sine is negative radical 3 over 2 down in quadrant 4. Distribute the 4/3 is your last step. 4 over 2 cancels, so 4/3 times 1/2 is 2/3. It's going to be minus, because of this negative, 2 radical 3 over 3 times I. And for the last piece, same idea. 6 times, what's the pi over 6 coordinate? It's radical 3 over 2, 1/2. You're in quadrant 2. So cosine is negative radical 3 over 2 plus I times 6 times sine is positive 1/2. So the complex number is negative, reduce this, 3 radical 3 plus 3i. All right, I'm going to stop this video here. In the second video, we'll finish out the worksheet.